Today we will see examples of angles formed by transversals on parallel lines. Example: the given diagram shows the intersection of rail tracks and road. The railway tracks are parallel. Similarly, the roadsides are also parallel. Based on this information, find the measure of x. This question may seem to be difficult, but it is a very interesting question. Let's solve it. Here we can assume that the railway tracks and the roadsides go infinitely without meeting. So, we can represent them as parallel lines. To solve this question, let's name them after taking some points on the lines. Similarly, we will also name the points formed at the intersection. Here we are given that the angle QBD is equal to 63 degrees. Here we see that the line AD and the line EH are parallel and the line PQ is their transversal line. Here angle QBD and angle PFE are alternate interior angles formed by the transversal of two parallel lines. So, they are equal. That is, angle QBD is equal to angle PFE is equal to 63 degrees. Now see, line PQ and line RS are also parallel lines and EH is their transversal line. We see that angle PFE and angle EGR are corresponding angles. Since they are corresponding angles formed by the transversal of parallel lines, they are equal. In this way, angle PFE is equal to angle EGR is equal to 63 degrees. But as you can see, angle EGR and angle HGR are both adjacent angles, but there is GE and GH are both rays moving in opposite directions. Therefore, the two angles together form a linear pair. That is, angle EGR plus angle HGR is equal to 180 degrees. Since we know angle EGR is equal to 63 degrees, we can easily find the value of angle HGR. Angle HGR is equal to 180 degrees minus angle EGR is equal to 180 degrees minus 63 degrees. Therefore, angle HGR is equal to 117 degrees. That is, the value of x in the given picture is 117 degrees. We can also solve this by a different method. For example, here line PQ and line RS are parallel and the line AD is their transversal line. We can say that angle QBD is equal to angle SCD is equal to 63 degrees because they're corresponding angles. Similarly, lines AD and line EH are parallel and RS is their transversal line. Here we can say that angle SCD plus angle HGR is equal to 180 degrees because we know that on parallel lines, interior angles on the same side of the transversal are supplementary. Hence, the sum will be 180 degrees. Therefore, we can say that angle HGR is equal to 180 degrees minus angle SCD. Since angle SCD is equal to 63 degrees, so angle HJI is equal to 180 degrees minus 63 degrees is equal to 117 degrees. That is, the value of x is 117 degrees. Next example. Line LM is transversal of line PQ and line ST. Angle MCQ is equal to 32 degrees and angle SOM is equal to 148 degrees. Show that line PQ and line ST are parallel. Here we see that angle MCQ and angle LCP are vertically opposite angles. Therefore, they will be equal. That is, angle MCQ is equal to angle LCP is equal to 32 degrees. Here, angle LCP and angle SOM are the internal angles on the same side of the transversal lines. If we add them, we get angle LCP plus angle SOM is equal to 32 degrees plus 148 degrees is equal to 180 degrees. If the pairs of interior angles on the same side of transversal are supplementary, then lines have to be parallel.
If a transversal line cuts two lines in such a way that the pair of interior angles
On the same side of the transversal are supplementary,
then we can say that those lines are parallel.
this makes it clear that the line PQ and line ST are parallel. Today we saw examples of angles formed by a transversal on parallel lines. In the next video, we will see some misconception related to them.